Good day, viewers, and welcome to your best learning hub for the sciences, Jalo Science Academy. I am Mohamed Jalo. In this tutorial, I will be taking you through your general mathematics, and we are going to look at number systems. Of course, talking of number systems, numbers are most often written in base 10, or in our everyday counting, we deal with base 10 numbers. But these numbers can also be converted to other bases other than the standard base, which is base 10. They can also be written in other bases other than base 10. For example, you have here 50 in base 10. You can write it as 50 ordinarily, or you write a subscript of 10, TEN. And it is advisable that you write 50 base 10 like this instead of writing 50 base 10. So this one is the most appropriate, and it is advisable that you write it this way. Well, it is not that this one is wrong, but it is to avoid confusion, because most students, when they write this, they'll tend to write it as 5010. Instead of 50 base 10, it now becomes 5010. So that's the reason it is advisable that you write the base subscript using the wordings other than the numbers. Of course, like I told you earlier, numbers can be converted from one base to another. So in this tutorial, we're going to look at how to convert numbers, base 10 numbers to any other base, meaning you can convert from base 10 to either base 2, base 3, base 4, 5, 6, 7, 8, as the case may be. And we are also going to look at how to convert from those ordinary bases, from base 2, 3, 4, 5, 6, 7, 8, 9, onto the standard base, which is base 10. Base 10 is also known as the decimal base, or we call it the denary base. It is the standard base in which we operate. So we look at how to convert from base 10 to any base, from any base to base 10, and we'll also look at how to convert from any base to any other base, meaning from one base to another, other than base 10. For example, you'll be required to convert from base 5 to base 7, wherein base 10 is not included or involved in the question. And we also look at how to convert decimal numbers that are in ordinary bases to base 10. We also look at how to convert decimal or fractional numbers that are in base 10 to base 2. And we'll also look at how to add, how to subtract, multiply, and divide number bases. And finally, we'll look at special cases of number bases. So let's begin with our conversion of number bases. Now, conversion of number bases, we're going to start off with, converting from base 10 to any base. Now, converting from base 10 to any base, what you do, the base 10 number given to you is what you are going to divide successively by the base in which you are converting to. So you're going to divide that number successively by the base which you are converting to till you arrive at a 0 and taking cognizance of the remainders. So that's the procedure. That's how you can go about converting from base 10 to any base. Let's look at some examples. We have these examples. We have to convert to these required bases. So the first one is 437 in base 10. 437 in base 10, we have to convert this to a number in base 5. So this 437 that is in base 10 is what we are going to divide throughout by 5. So we'll do our division this way. Five cannot go into 4, so we combine the 4 and the 3, 43. 5 into 43 is 8 times, with a remainder of 3, because 5 by 8 is 40. Bring the 3 to the 7, becomes 37. 5 into 37 is 7 times, with a remainder of 2, because 7 by 5 is 35, and 37 minus 35 is 2. Use 5. 5 into 8, 1 remainder 3. Remainder 3 becomes 37. 5 into 37, 7 times with a remainder of 2. We use 5 again. 5 into 17, 3 times with a remainder of 2. We use 5 again. 5 into 3 is 0, the remainder of 3. So we indicate an arrow pointing from bottom to top. Our answer, therefore, is 3, 2, 2, 2, 2, 2, 2, and the base we have is a base of 5. So this becomes our answer for the first example. We look at the second example. We have 226. We have to convert it to a number in base 8. 226 in base 10 to a number in base 8. So like we did for the first example, that's the same thing we are going to do here. So 226 is going to be divided throughout by 8. So 8 into 22, that's going to give us 2 times with a remainder of 6 that will remain, okay? Because we know 8 times 2 is 16, and 22 minus 16 is 6 times. So we bring the 6 here, it becomes 66. 8 into 66. 8 by 8 is 64. So that means 8 goes there 8 times with a remainder of 2. And then we use 8 again. 8 into 28. 8 by 3 is 24. So 8 goes here 3 times with a remainder of 4. And then we use 8 again because our target is to divide until we arrive at 0. 8 into 3. 8 cannot go into 3. 0, and we write 3 as the remainder. So indicate our arrow from bottom to top. Our answer therefore is 3, 4, 2 in base 8. So this is the answer to the second example. The third example, which is 27. This number is written without a base. Any number written without a base is having a base of 10. So if you see a number without a base, just consider that it is in base 10. So this we have to convert it to a binary base. So this is base 10. So 27 is going to be divided by 2 throughout. 2 into itself is 1. Into 7 3 times with a remainder of 1. We use 2 again. 2 into 13, that's 6 times with a remainder of 1. We use 2. 2 into 6 3 times, 0 as the remainder. 2 again. 2 into 3 1 with a remainder of 1. And we use 2 again. 2 into 1 is 0 with a remainder of 1. So indicate our arrow from bottom to top. So our answer is 11011. 11011 in base 2. So this is how we can convert from base 10 to any base. Next, we're going to look at the other aspect, that is converting from any base to base 10. In converting from any base to base 10, there are 2 applicable methods. One is a power expansion method. 2 is a successive multiplication method. So we're going to start off with the power expansion method. Okay, so we have these ones to work out here. So we have to convert the following to base 10. Looking at the power expansion method, take the first example. 3, 2, 2, 2 in base 5. The base in which the number is written is 5. So we take this first number, 3, multiplied by the base 5, put it in bracket, plus these 2 multiplied by the base 5, plus these 2 multiplied by the base 5, plus these 2 multiplied by the base 5. So these 3 here, these 2, these are the 2, and this one. But this is unit, tens, hundreds, thousands. So unit number gets power 0, this gets power 1, this gets power 2, this gets power 3. So 5 to the power 3 means 5 times 5 times 5, which gives us 125. So this is 3 multiplied by 125, added to 2 multiplied by 5 to the power 2, that is 25, 5 times 5, plus 2 multiplied by 5 to the power 1. Any number or letter to the power 1 is a number or letter itself from your laws of indices. 2 multiplied by 5 to the power 0 is 1. Any number or letter to the power 0 is 1, provided the number that has been raised to the 0 is a non-zero number. Because if it is a 0, then it is undefined. So 3 multiplied by 125, you use your calculator. That gives us 375. 2 multiplied by 25, that is 50. 2 multiplied by 5 is 10. 2 multiplied by 1 is 2. So you add this. 375 plus 50 plus 10 plus 375. And that gives us 437 in base 10. So this becomes our answer to the first example. Come to the second one, which is 342 in base 8. 342 in base 8, also using the power expansion method. So 3 here, this number, we multiply it by the base 8, plus 4 multiplied by the base 8, plus 2 multiplied by the base 8. Unit number gets power 0, this gets power 1, this gets power 2. 8 to power 2 means 8 times 8. So this is 3 multiplied by 8 is 64, plus 4 multiplied by 8 to power 1 is 8, plus 2 multiplied by 8 to power 0 is 1. So go for your calculator. 3 multiplied by 64, that gives you 192. 4 by 8 gives us 32, plus 2. So adding this, and this added, 2 plus this, 2 plus this, 2 is 6. 3 plus this is 12, 2 carry 1, plus 1 is 2. So we have 226 in base 10. Okay, and finally we go for the third example, 11011 in base 2. 11011 in base 2, it is 1 multiplied by the base, this first one multiplied by the base, plus 1 here multiplied by the base, plus 0 multiplied by the base, plus this 1 again multiplied by the base, plus the other one multiplied by the base. So this gets power 0, this gets power 1, this gets power 2, power 3, and power 4. 2 to power 4 means 2 times 2 times 2 times 2. And that is gonna give us 2 by 2, 4, 4 by 2, 8, 8 by 2, 16. So it is 1 multiplied by 16. 2 to power 3 is 8. That is 1 multiplied by 8. 0 multiplied by 4. Or 2 to power 2 is 4. 1 multiplied by 2 plus 1 multiplied by 1. So this gives us 16 plus, this is 8. Of course, this is 0. 1 by 2 is 2. 1 by 1 is 1. So this plus this 24 plus this 26 and this 27. So this is how you can go about converting from any base to base 10. So this is the power expansion method. Now let's look at the successive multiplication method. We're going to deal with the same examples. Dealing with the same examples, example 1 is 3, 2, 2, 2 in base 5. 3, 2, 2, 2 in base 5. So what we do? We take this first number 3, we multiply it by the base 5, and to it we add these 2. 3 by 5 is 15, plus this 2 is 17. Then this answer that we've arrived at, 17, we multiply it by 5, and to it we add this other 2. 5 gives us 85 plus 2, 87. So this 87 that we've arrived at, we multiply it by the base 5, and to it we add this final 2. So go for 87 by 5, that gives us 435, plus 2, that gives us 437. Our answer therefore is 437 in base 10. So this is the first example. Okay, we look at the second example. The second example is example 2, 342 in base 8. We have to convert this to base 10. So like we did for the first, use this number multiplied by the base 8, and to it we add 4. So 3 by 8 is 24, plus this 4 here, that gives us 28. Then we come 28 multiplied by the base 8, to it we add 2. 28 times 8, that gives us 224, and 224 plus this, that gives us 226. Base 10. And then finally we go to the third example. The third example is 11011 in base 2. So what we do, take this 1 multiplied by the base 2, to it we add this 1. 1 times 2 is 2, plus this 1 is 3, and then this 3 you multiply by the base, to it you add this 0. 3 by 2, 6, plus 0 is 6. Take the 6 multiplied by the base 2, to it you add this 1 here. 6 by 2 is 12, plus this 1, 13. The 13 you multiply by the base again 2. Mind you, you've exhausted this, and this, and now you finally use this. 13 by this is 26, plus 1, 27. If you observe, you finally you got the same answers: 437, 437, 226, 226, and 27, and then 27. So irrespective of the method you choose to use, you arrive at the same answer. But in most of the textbooks that are available, it is the power expansion method that is being used. So this is how to convert from any base to base 10. Now we're going to look at how to convert one base to another other than base 10. We'll convert the following to the required bases. Okay, so we have to solve these particular examples. So these are the numbers that we have to convert. 134 in base 6 to a binary base. Binary base means you convert it to base 2. But you can't convert directly from 6 to 2. You first of all need to convert each of these numbers to base 10. From there, you can now convert to the required base, because base 10 is the standard base, we call it the transition base. So we have to convert from 6 to base 2. So what we do, from 6 first, we come to 10, and from 10 now we go to 2. So this is how we go about it. So 10 is the transition point. So we're going to convert this to base 10. Well, it is up to you as to whether you want to use the power expansion method or if you want to use a successive multiplication method. Any one of the two will be okay. So in this case, let's use the power expansion method. Power 0, power 1, power 2. 6 to the power 2, that's 6 times 6, 36. So we have 1 by 36 plus 6 to the power 1 is 6 plus 4 multiplied by 6 to the power 0 is 1. 1 by 36 is 36. 3 by 6 is 18. 4 by 1 is 4. So if you add this, this, and this, 4 plus this 8 is 12, and plus this gives you 18. 8 carry 1, 1, 2, and this 5. So you get 5, 8 in base 10. So this number that you've arrived at is now what you are going to convert now to base 2. So we say here 5, 8. We're going to convert it to the binary base 2. 2 into 5 is 2 times, remember 1. Bring the 1 to this becomes 18. 2 into 18 is 9 times, no remainder. We use 2. 2 into itself is 1. Into 9, 4 times with a remainder of 1. We use 2. 2 into 14, 7, no remainder. And then 2. 2 into 7, 3 with a remainder of 1. 2 into 3, 1 times with a remainder of 1. And then we use 2. 2 into 1 is 0 with a remainder of 1. Arrow pointing from bottom to top. So our answer, therefore, is 111010. 111010 in base 2. So if you observe, each time you are converting to a base, the highest number that should appear in that base should be 1 less than the base. If you are converting to base 3, the highest number in base 3 is 2. The highest number in base 4 is 3. The highest number in base 5 is 4. The highest number in base 6 is 5. In base 7 is 6. In base 8 is 7. Okay? In base 9 is 8, as the case may be. So that's it. Second example, we have 3, 4, 4 in base 5. 3, 4, 4 in base 5. So here also, if you want to use the power expansion or use the successive multiplication. So we stick to the power expansion as it is the one that is used in most textbooks. 3 by 5 plus 4 by 5 plus 4 by 5. Power 0, power 1, power 2. 5 to power 2, that's 25. 3 by 25 plus 5 to power 1 is 5. 4 by 5 plus 4 by 5 to power 0 is 1. 3 by 25 is 75 plus 4 by 5 is 20. 4 by 1 is 4. This and this gives us 95, and this gives us 99 in base 10. So this number can now be converted to the octal base. Octal base means base 8. So 9 is going to be converted to 8. 8 into 9, 1. Remember 1, bring the 1 becomes 19. 8 into 19, 2 times 8 we know is 16. So it's going to be 2 times with a remainder of 3. We use 8 again. 8 into 12 is 1 with a remainder of 4. And we use 8 again. 8 into 1 is 0 with 1 being the remainder. Our answer therefore is 143 in base 8. So this is how you can convert a number in one base to a number in another base other than base 10. So this is the conversion. So we look at the third example. Base 7. We have to convert it to base 3. So we first of all have to convert it to base 10, which is 1 multiplied by 7, bracket, plus 2 multiplied by 7, plus 4 multiplied by 7. This gets power of 0, is the unit number, power 1, tens number, power 2, the hundredths. So 7 to the power 2 is 7 by 7, that is 49. So it is 1 by 49 plus 2 by 7 to the power 1 is 7 plus 4 multiplied by 7 to the power 0 is 1. So 1 by 49 is 49 plus 2 by 7 is 14 plus 4 by 1 is 4. So 49 plus this is going to give us 63. and plus this gives us 6, 7. That is now in base 10. So this is what we are going to convert to base 3. So this 6, 7, we can convert it to base 3. 3 into 6, 2 times. 3 into 7, 2 times the remainder of 1. 3 into 21, 7 times. 3 into 22 rather, 7 times remainder 1. 3 into 7, 2 times the remainder of 1. And 3 into 2, that's 0, remainder of 2. Our answer, therefore, is 2, 1, 1, 1 in base 3. So this is how we can convert from a number in one base to a number in another base other than base 10. So next up is conversion of a decimal number to base 10. Okay, we have examples on the board. Convert the following decimal numbers to base 10. 101.011 in base 2. So we start off with that. So doing this conversion, converting it to base 10, 1 multiplied by the base 2, added 2, take the 0, multiply by the base 2, we add it to, take this 1, multiplied by the base 2. This is the whole number part, this is the decimal part. So this whole number part, this is the unit tens, hundred, so this gets power 0, power 1, and power 2. Then we put our point, come for this number, 0 multiplied by the base 2, added 2, 1 multiplied by the base 2, and also added to this last figure 1 multiplied by the base 2. This is the decimal part. This number is the 10th number. T-E-N-T-H, 10th. This is hundredth, this is thousandth. So this 10th gets a power. 10th means 1 upon 10. 100 means 1 over 100. And 1000 means 1 over 1000. So this can be written as 10 to the power negative 1. Of course, 100 we know is 10 to the power 2. So this can be written as 10 to the negative 2. And this can be written as 1 upon 1000 is 10 to the power 3. So 10 to the power 3 is 1 upon 10 to the power 3 is 10 to the negative 3. So this first one gets power of negative 1, negative 2, negative 3. Negative 1, negative 2, negative 3. So that we simplify this. 2 to the power 2 is 4. So let's do it right away. 1 by 4 is 4. Plus this gives us 0. Plus this gives us 1 point. And this is the same as 0 multiplied by 1 upon 2 plus 1 multiplied by 1 upon 2 to the power 2 plus 1 multiplied by 1 upon 2 to the power 3. So this will give us 5. Put a point here. And then this automatically gives us 0. And this will give us 1 multiplied by 1 is 1. Over 2 squared is 4 plus 1 multiplied by 1 is 1. 2 raised to the power 3, that is 2 cubed, that gives us 8. So what we do, this 5, we find the LCM here, 8. 4 into 8, that is 2 times, 2 by 1 is 2. Plus 8 into itself is 1, 1 by 1 is 1. So this will give us 5. This implies that it is 5 whole number, 3 upon 8. But you can divide 3 on 8. So this is now in base 10. But you can write it like this. If you want to write it as a decimal, that is 5.3 divided by 8, that is 0.375. So you have 375 in base 10. So either this or this, any of the two is correct. So we go to the second example, which is 241.33 in base 8. So this is the whole number part, this is the decimal part. So here it's 2 multiplied by the base 8 added to 4 multiplied by the base 8 further added to 1 multiplied by the base 8. This is a whole number part, so this gets power 0, unit number, power 1, power 2. And here we say 3 also multiplied by the base 8 plus the other 3 multiplied by the base 8. This is the 10th number. It gets power of negative 1, 100 power of negative 2. So 8 squared, that is 64. So we have 2 multiplied by 64 added to 8 to power 1 is 8. 4 multiplied by 8 plus 8 to power 0 is 1. So this will be 3 multiplied by 1 to the power 8 upon 1 plus 3 multiplied by 1 upon 8 to power 2. So this is what we have. So in this situation, 2 by 64, that gives us 128. 4 by 8 is 32, and this gives us 1. So this is 3 over 8 plus 3 over 64. So 128 plus this gives us 160, and this gives us 161. So we find the LCM 64. 8 into 64 is 8 times 8 by 3 here gives us 24 plus 64 into itself is 1. 1 by 3 is 3. So this implies that it is 161.27 upon 64 in base 10. Or use your calculator to you get 0.421875. So what we do, we can say 161.422 in base 10. So this is the answer to the other example. So we look at the third example, third one, which says 112.322 in base 6. 112.322 in base 6. We have to convert it to base 10. So it's 1 multiplied by the base 6 plus 1 multiplied by the base 6 plus 2 multiplied by the base 6. Put a point, this gets power 0, power 1, power 2. 3 multiplied by base 6, negative 1, plus 2 multiplied by base 6, negative 2 power, plus 2 multiplied by base 6, negative 3 power. So with this, we can further simplify. 6 squared, that is 36. So 1 by 36 is 36, plus 6 to the power 1 is 6. 1 by 6 is 6. Plus 6 to the power 0 is 1. 2 times 1 is 2. Put a point. So this will give us 3 multiplied by 6 to the power 1 is 6. Plus 2 multiplied by 1 upon 6 to the power 2 is 36. Plus 2 multiplied by 1 upon 6 to the power 3 is 216. So now with these that we have, we do our simplifications further. 36 plus 6, 42, plus this 44. So it is 44. Point. This will be half, 3 upon 6, and this will give us 1 upon 18 plus, and this will give us 1 upon 108. So what we do, these are 3 fractions being added. We find the common denominator. That's the LCM. 44, common denominator is 108. 2 into 108, that is 54. 54 by 1 is 54 plus 18 into 108, that's 6 times. 6 by 1, there is 6 plus 108 into itself is 1. 1 times 1 is 1. So this implies 44. This plus this is 6. 60 plus this 61. 61 upon 108. So this is in base 10. Or you have 44 point. You divide 61 divided by 108. That gives us 0.5648. So we get 0.565. So that is 565 in base 10. You can pause the video, take a screenshot, and practice how to convert from one base to another other than base 10, and also how to convert decimal numbers to base 10 numbers.